चलिए दोस्तों शुरू करते हैं विदाउट वेस्टिंग ए टाइम. टुडे वी हैव दिस lab is a route reflector lab part 1. So we will do the series on the route reflector. We'll go the deep dive in the on each part of the section with respect to route reflector. Okay, these are the few information I put it here. RR, what is RR? Is the route reflector. What is the job of route reflector? It solves the one problem is the requirement of full mesh of iBGP peers. So we will see why do we require a full mesh of iBGP peers, and this is the formula I put it. What is the number of iBGP required in if we have a 4 router, if we have this topology? So how many total iBGP number of peering will be required? This is our n, and n minus 1 divided by 2. So we have a 4 router. So it put 4, 4, 4 minus 1, 3, 4 plus 3, 12, 12 divided by 2. So 6 number of iBGP peering in this topology required. So what can be the different type of peering and neighborship with the RR? RR can have any peering with the eBGP neighborship, iBGP client, and iBGP non-client. And after that, I put the definition of BGP split origin. What this rule says, route received from a one iBGP neighbor will not be forwarded to another iBGP neighbor. Means if we have an iBGP session between this router 2 to router 1 and router 1 to router 3 and router 3 to router 4, let's suppose this R2 have advertised the one route to this iBGP neighbor. So this iBGP neighbor will not advertise, this IBGP will not further advertise this route to R3. So this is the meaning of this rule, iBGP return rule. And this is the common rule for the advertisement of the route reflector. A route learned from a non-RR client is advertised to RR client but not to the non-RR client. A route learned from RR client is advertised to both RR client and non-RR client. A route learned from eBGP neighbor will be advertised to both RR client and non-RR. How RR will prevent the loop? So let's jump to the configuration part. First, we will see how we can configure iBGP neighborship on the Cisco IOSXR router. So I will start from the router XRV2, then XRV1, then XRV3, then XRV4. Let's jump to the configuration. So here we are on the router 2. So let me show the current config. So I have already configured the IGP protocol. We are using ISIS. With the help of ISIS, this protocol, we are able to get the reachability between the loopback 0 addresses. Okay. So if you see the show route, if I run the command, so I have an router 1 loopback. This is the route. This is the route for router 2, correct, router 3, and router 4. We have a 4 router. So for the all 4 router, we have a loopback 0 address in the routing table with the help of ISS protocol IGP. IG protocol ISS. Let's do the ping. So we have an end-to-end reachability. Let's ping to the 3.3. We have an reachability. Correct. So let's see now. We will see how to enable a iBGP neighborship. How to configure iBGP neighborship in the Cisco IOSXR ASR9000 router. So first we'll do configure router 2 and router 1. We are on the router 2. Let's configure iBGP peering with router 1. So do the show route for router 1. This is the loopback address of the router 1. So this route is coming from gigabit ethernet 0 slash 0 slash 0 slash 0. Okay. So we will use the BGP AS1 router BGP1. Okay. In the IOSXR we need to activate the address family first. So we'll we will use the address family IP for unicast. So first we need to do the commit here. So here in the global router BGP mode, we are activating this address family IP for unicast. Once the address family activated in the router BGP only context, we need to came out from the address family context. In the router BGP context only, we need to define the neighbor. Let's do neighbor, and we want to peering with the router 1, 1.1. Okay. After that, we need to configure the in the neighbor update source. So all the updates for the BGP want to go from the loopback 0. Then remote AS we need to configure as an iBGP number. So all router have an AS number only, AS number 1 only. And then we need to call the address family for this engagement neighbor. Root to the show. So this is the command line required to configure the BGP. Here we in the router BGP AS number 1 context. After we define the neighbor remote AS update source and activating the address family under the neighbor also. So let me do the commit. Okay. So if we do the whole config, if we check, so we have activated the address family, required address family first in the global BGP process. After that, we have called the address family under the neighbor also. So let's jump to the router 1 configuration now. So we have completed the BGP configuration on this router 2 with neighborship we have configured with router 1. Now we'll go to the router 1. We have to define the two iBGP session, one with the router 2, one with the router 3. So here we are on router 1. We need to define a two iBGP neighbor, one with the router 2, one with the router 3. So let's check the running configuration first. So again we are using ISIS. Okay. We check the routes. We have a route. We have to define neighborship between 2 and 3. We have a route for 2 and 3. These are the directly connected router with this router. Okay. Let's jump to the again. Go to the router, BGP, AS number 1 we are running. Let's activate address family. Then we need to do the commit. Let's come out from the address family. Now we are in the BGP context only. Let's type the neighbor IP. We want to define neighborship with the two router 2 and 3. Let's do the first two. Then we have to define the remote AS is 1. Date source is loopback 0. Address family IPv4 unicast. And that's it. Let's go do the same configuration from the router neighbor router 3 also. 3.3.3 remote AS and update source, then calling the address family under name. Let me do the root. Let's see what we are going to commit. So this is the configuration we are going to commit for the two neighbors. Where is now one neighbor should came up, that is with the router 2, as we have already defined the neighborship on the router 2. So let's check how we can just show BGP all summary. Let's do this way. Here let's just wait. Neighborship should come up. So now we can see that BGP neighborship came up, but we did not receive any route, as we are not advertising any route in the BGP, so we are not receiving any route. Okay, let's jump to the router 3, where we have to define the neighborship with the router 2 and router 4. So here we are on the router 3. We need to define neighborship with the router 1 and router 4. Okay. So let's quickly check the show run. We have defined the IP address and IGP ISR. There, let's check the route. We have a route. So we have a route for the 1 and 4, another 2 and 3. Let's again jump router BGP1. Then we need to activate address family, as we are using the IPv4 unicast family. So let's activate this. After this commit, we need to go out from the address family context, and let's define first is the 1.1.1.1. Then we put the remote AS1, then updates source is loopback 0, then call the address family under neighbor context. So let's came out now here from the neighbor also. Let's do the same for the neighbor 4 also. 4.4.4. Remote AS is same, and update source we are using loopback 0. Address family we are using IPv4 unicast. We want to region. Let's do root, and let's check what we are going to commit. Let's do the commit. Let's jump to the final router 4, where we have to define the neighborship with the router 3. On final router 4. Let's check for assurance first. Let me do the login first. Sorry. Okay, let's do the show run. Here we have an ISIS config to get the reachability with the loopback addresses. And let's check the routing table. Here we are getting the routes for all of the 4 routers. We need to, as per the physical connectivity, this router is connected with the router 3. So we have to configure the peering with router 3. So let's go to the again in the context router BGP1, and then let's activate the address family, unicast, commit, waits. Okay, let's came out for the address family. Let's neighbor context. Neighbor is 3.3.3. Then we need to the remote AS1. Address family we need to activate before that update source. Let's do that. Then address family IP we call unicast. Let's do the root. You see the how the context is changing. First we go to the BGP context, BGP, then we have the neighbor is showing neighbor, then we have the address family. Under the neighbor we have address family. Let's do the commit. Okay, let's jump back to the our first router, which is router 2. So now we have done the iBGP configuration. We have configured one neighbor on this router 2 with this router 1. Here we have configured the two iBGP neighbor with this router, with this router. Here also we have configured the two iBGP with this router 1 and router 4. On the router 4, we have one iBGP in the router 3. So we have an iBGP neighborship we have configured as per the physical link connectivity. Okay. So now we'll go back to the router 2. Okay, we will see how we can advertise the network in the BGP, and after that we will see this rule in action, which is saying with normal iBGP role, when router receive a route from iBGP neighbor, it will not forward to another iBGP neighbor. That is rule is BGP split origin rule. So we'll advertise the one route from router 2. So this route should uh, reach to router 1, and this should not go forward to the router 3. Let's jump to the router 2 first. So here we are on the router 2. Let me log in first. Have the logged in. Okay. So we'll see how we can advertise network in the BGP. There are multiple way we use the redistribute connected here. So let me do first thing. Let me show you the current configure the router BGP. So this is the configuration we have, and these are the interfaces we have and connected interfaces like this physical interface and this loopback interface. So let's do to the let's create the one more loopback. Okay, let's create one more loopback 100, and let's put the IP address of PV for address 100.100.100.100/32. Let's do the commit. What we have done, we have configured the one loopback. Let's advertise this loopback in the BGP. Let's do with the network statement. Here we go under the address family router BGP. Under the address family, we need to put a network statement network 100.100.100.100/32 root. Let's see what we are going to commit. We are commit. So we have advertised the network in BGP with the network statement here on the router 2. So if we check the BGP table, normally we check the routing table, the routing table. Let's check the BGP table. Show BGP is the command. So we can see that with this arrow sign, the best route, okay, and this route in the routing table. And next up is 000 because this route is only by advertising this route. So let's check show BGP all summary. So it's showing in the address family IP for unicast. This neighborship is up. Okay, let's see this route. We are advertising this router's neighbor. Show BGP neighbor 1.1.1.1 neighbor advertise route. Okay, it's advertising this route with the next hop 2222. Okay, next hop is the this router loopback 0 address. So let's go to the now this router is connected with the router 1. Let's go to the router 1 now. Since I'm putting the wrong password, no problem. Here we are. Okay, so let's check route here. Show route. We can see that we are getting with this B is the BGP, and we are getting the route here. This route here advertised from router 2, and this is the next hop of the 222 is the route. If we just show route for 100.100.100.100 slash 32, we can see that this route is coming via BGP. AS number is 1. Distance metric for the iBGP 200. Okay, it's internal route from the last approx 2 minutes coming. This is the neighbor zero in this route. Okay, which is the show BGP summary. So we can see that we are getting the state prefix received, RCD received. We are getting the one prefix from this neighbor. Okay, so we have two neighborship on this router, one with the router 2, one with the router 3, and from the router 2 we are getting this one prefix. Let's see, are we advertising this prefix 100.100.100 to this neighbor or not? So BGP neighbor 3.3.3.3 advertise. So this is not advising. This is the rule of split horizon. A route is coming from the iBGP neighbor from router 2, and this router 1 is not advising this further route to router 3. So this is split horizon we have seen in the action. A route is coming on this router 1, route is coming from router 2 iBGP neighborship, and this is not advertising this route further to another iBGP neighbor. This is called rule of split horizon. And this is the only region is full mesh is required, because normally this router is not advertising, so we'll not be able to get the reachability end to end. So this is the region we need to configure iBGP full mesh. So what we have to do, on the router 2 we need to configure the also full mesh peering with the router 3, so router 3 can also get the route from router 2. So here we on the router 3, let me log in. If we check the show routing table, so we don't have any route 100. However, we have a BGP neighborship up in place with the router 1, but router 1 is not advertising the routes. We have checked on the router 1 also, it's not advertising. We are checking the router 3 routing table also. We are not getting any route of the 100.100 which we have advertised from router 2 with the help of network statement. So this proves iBGP split version true. So with the help of configuration, we have seen that why do we require a full mesh peering first thing. How this iBGP split version rule work in action, we have seen correct while we advertise the route from router 2 to router 1. Route 1 didn't for this route to router 3, so this was the rule of split origin. And this is the reason we require a full mesh. Full mesh means we have to, if we have to send this loopback 100.100.100.100 prefix from router 2 to router 3, we need a peering with between router 2 and router 3 also, between router and router 4 also. This is the reason full mesh is required. So we have covered this iBGP split version and why do we require a full mesh, that is also correct. And now let's jump to the RR. Let's configure the RR configuration. So what we will do, we will configure this router 1. Router 1 with the route reflector. So on this route reflector, we'll configure the 3 BGP peering session with router 2, router 4 and router 3. That's it. So I click configure the route reflector configuration. Let me show you what the configuration I have done on the route reflector. As you have decided, RR with the route reflector, I have changed the host name also to the RR to R1 to RR. And this is the configuration I have done. I have defined the three neighbors. Under all of the three neighbors, I put the command route-reflector-client. So I am this router 1 RR is the route reflector, and 2, 3, and 4 router are the client. Okay. So now that's it. This is the configuration only I have done, and all the direct peering I have deleted. So now we have only one peering or all of the router. So router 2 is peering with this RR only. Router 3 also have only one iBGP peering with this RR only. Router 4 also have peering with this RR only. There is no peering between 4, 3 and 4, 2 like this way. Okay. So and now we jump to the router 3. We'll see are we getting the route for the loopback 100 which we have advertised on the router 2. Earlier we were not receiving while we have not implemented the route reflector configuration. So here we are on the router 3. Earlier we were not getting the route for the loopback 100. So let's see the route for the loopback 100. Are we getting now or not? Okay, so here we can see that we are getting the route now. Okay, and if it is a show BGP summary, earlier there was no prefix received. Now we have received this prefix from 1.1. 1.1 is the our route reflector client. If we take the route in the BGP table or route on this XRV4 also, okay, if we check the route for the XRV4, so we are getting the route now for the loopback 100.100 prefix, which we have advertised from the router 2. And one more important aspect we need to remember that route reflector will not change the next hop. So this route is showing it's coming from the 2 to 2. This is the actual router which is advertising with the help of network statements to this. Okay. So this is the important point. Route reflector does not change the next hop. So we have seen that how with the help of route reflector there is no full message required, and we can reduce the number of peering, correct, and we can get the routes. So now we have seen that how with the help of route reflector configuration, we were able to extend the route without conflicting the full mesh peering. So here in the rule of the RR, in the second rule, we say route learn from RR client is advertised to both RR client and non-RR clients. So here this XRV2, our router 2 is the client of this route reflector router 1. So when this router 2 RR client have advertised the route to route reflector, what route reflector will do? So this will advertise the route to both client and non-RR client. So this will advertise the same prefix to same again to the let's this router 2 advertise prefix 100.100.100.100 to route reflector, and route reflector what will do? This will reflect the route to the every client. So this will send the route update to this router also. Okay, so here we can see that update from 111. So this is saying this route is coming from route reflector, prefix is this is denied due to next hop is our O1 address. Okay, once this router will receive the O1 route from this route reflector, this will reject because this will see this route is my route only, which I have originated with the help of next hop address.